Right. Hello, everyone. Thank you for joining this session. My name is Francois Levasseur. I'm a master's student at Memorial University of Newfoundland, and I'm going to talk to you about Dorset Harpoon head 3D morphometric variability in the Canadian Arctic and Subarctic. So the Dorset Paleo-Inuit lived around 2,500 BP to 500 BP. Their range consisted of the majority of the Canadian Arctic and parts of the Subarctic, as well as parts of Greenland. They were part of the Arctic small tool tradition, which relied heavily on microblade technology. These were mostly made out of chert, but they were supplemented with ground slate technology. They had a prominent art scene, which intensified in the later period and has been interpreted as a result of a personal coping mechanism with a shifting climate. Unlike the Inuit, the Dorset did not have dogs or dog-drawn sleds, nor did they have bow and arrow technology or bow drill technology. All of their the holes they produced on their organic artifacts were done by gouging. And there's only indirect evidence that they had watercrafts. So their primary subsistence base was the hunt for marine mammals, primarily seals and walrus. For this, they used harpoons, which is a composite tool consisting of harpoon heads, shafts, and the line which was attached to the harpoon head. The harpoon head's ability to toggle is what ensured the successful hunt. Once the harpoon head successfully penetrated the skin, blubber, and muscle of the prey, pulling on the line and the morphology of the harpoon head allowed it to turn 90 degrees to be perpendicular with the skin of the animal, which allowed the hunter to pull back the prey successfully. So various components of the attributes of the harpoon head. On the dorsal side, you have the line hole and the spurs on the proximal end. On the profile, you can see that they had a blade slot, which they inserted an end blade on it. It was modular, so if the end blade broke, they could easily replace it. The asymmetric profile, the cutting out at the bottom of the harpoon head, aided in the toggling, so that when they pulled it back out, the symmetry just didn't come right back out of the hole. It actually turned. The line hole on the ventral side is pretty much the same, and the spurs still at the proximal end. Hopefully those don't change places. And on the proximal end, you had a rectangular four-shaft socket. So my research questions were, what is the nature of intrasite and intersite harpoon head variability? Is intrasite variability consistent between sites? And what does harpoon head variability reveal about cultural transmission processes? I worked with collections from 3 sites across the or across Canada. The first site is the Satut site, which is located on the northern coast of Baffin Island. The second site is 1,200 kilometers to the south, on an island off the coast of northern Quebec, though it is technically in Nunavut waters. And the third site is Phillips Garden, which is 1,700 kilometers to the southeast of Typological on the island of Newfoundland. My total sample size was 100, specifically 5 from Typological, 29 from Phillips Garden, and 66 from Satut. These ranges were established using all available dates, whether C14 or AMS, and include the 2 sigma criterion. Typological, the younger dates reflect the first stratigraphic level, whereas the older dates represent the second level. For Satut, this represents 2 contemporaneous house features, which have an occupation layer of only 35 centimeters. It was occupied repetitively from the fall to the end of winter. Phillips Garden encompassed over a dozen house features that span almost 1,000 years. So in terms of methodology, I used a structured light scanner called the Einscan SP, which is produced by Chinese manufacturer Shining 3D. It uses a turntable to scan the artifacts at the degree of turn that I choose. The static configuration of the original mount made me change to a more flexible arm mount that allowed me to position the scanner exactly where I wanted it, and also limited the manipulation of the artifact because they're quite fragile. Structured light scanner projects a pattern light on the object and uses two cameras to capture morphology, which is then translated to point cloud in pretty much real time. Scan takes about 20 to about an hour, depending on the damage of the harpoon head. Harpoon heads with an intact blade slot and 4-shaft socket were harder to scan. The EinScan software does an incredible job at aligning all the point clouds for each individual scan pretty automatically. Total processing time to create the mesh is around 3 minutes after all the scans are completed. Right here you have harpoon heads from all 3 sites. You can see that they vary in morphology, but they all share the same attributes. For node placement, I used a software called GOM Inspect. There's a free version that's pretty powerful. I placed surface curves along the surface of the harpoon head to help locate exactly where to place the nodes. For example, along the line hole, I was able to see exactly where the carving started, where it started to dip, and place the node exactly at that point. I placed a total of 31 nodes across the harpoon head, and each of these nodes were then I took a measurement between each single node for a total possible of for a total of possible 465 individual measurements. However, due to the incomplete nature and the degraded nature of the harpoon heads, not all nodes are. It's not possible to place all of the nodes, and this became a problem early on when I was testing it with PCA, which didn't accept incomplete data sets. It was very patchy, as you can see. What I did to circumvent this was I grouped nodes in specific variable sets, and that represented certain attributes and other morphological areas. The last batch is actually dependent on other variable sets and uses a surface curve between 2 points, and then I use percentage intervals to place points between the 2 first points, because a lot of these areas there's no way to place the points objectively. This resulted in much less patchy data sets. However, it also resulted in widely varying sample sizes. I'm happy to be able to share some preliminary results. I only finished data acquisition about a month ago. For the first variable sets, with the first variable set, which consists of nodes representing the side morphology, they clustered very well by site on the scatter plot, representing the first and second principal components. The double house feature Satut site, as expected, clustered very tightly, whereas the Phillips Garden site, which has been interpreted as an agglomeration site and a site where groups migrating south from the Arctic met, it shows considerable variability, which is also consistent with other artifact types and architecture. This interpretation may also be supported by the fact that the Typological group, the Typological site groups closer to the Phillips Garden, even though it is geographically closer to the Sawtooth site. Proximity does not ensure contact. Thus, the cultural transmission and the maintenance of cultural traits may result from varying contact through differing migration and trade networks. This, though, it was in one of my original variable sets. It includes a 3-point total length of the harpoons. It shows the same phenomenon of clustering between each and every site. Most of the variable sets indicate the same exact phenomenon, but it gets interesting when looking at the proximal area between the line hole and the fork. On the ventral side, there's greater consistency between all the sites. They all lump together. This is you can see it on the dorsal side as well, though it shows a bit more clustering than on the ventral side. I wanted to see if this was this phenomenon was just limited to the previous variable set, or if it was it also extended to the rest of the proximal area of the harpoon head. So I included the node for the spur, but it resulted in further clustering by site. These results indicate that certain attributes, while important for the overall functioning of the harpoon, changes in morphology may not affect performance. The same can be said for the whole distal area, the line hole, the spurs, and the foreshaft socket. However, the area between the line hole and the fork have remained consistent across time and space, indicating that it may be pivotal to the proper functioning of the harpoon head, and that and its ability to toggle, making it ill-advised to deviate from previously established cultural blueprints, to a lesser extent on the dorsal side. Now on to a few notes on the intrasite results. I've only started to delve into the analysis of the intrasite data. Due to the size of the collection, the sawtooth, and the depositional history of the sawtooth collection, I had hopes of finding individual manufacturers through morphometric variability. However, I'm still trying to figure that out now, and whether it's possible to do and how to do it. Initial tests with k-means clustering basically just cut it according to size and disregarded proportion completely. The sum of the eigenvalues can be used as a preliminary value to assess intrasite variability for sawtooth, which clustered pretty tightly on the intrasite level, has an eigenvalue of 93, whereas Phillips Garden had one up to 264, which is consistent with previous interpretations of the site. Most harpoon head attributes can incorporate variations without affecting proper functioning. However, the area between from the proximal end of the line hole to the fork, which is consistent in proportion between all collections, indicates its importance for proper functioning. Also, harpoon heads from individual sites remain most consistent with each other when compared to other sites. Now, work to come. I still have the intrasite principal component analysis to complete for Phillips Garden and sawtooth. I also have a wish to explore other means to evaluate variability, and I also hope to find a way to assess whether I can find individuals through morphometric variable data. Work in the future. I hope to add more collections to this sample, because I'm pretty sure it could reveal a lot about traditional knowledge and specifically traditional technical knowledge, different areas throughout the Dorset range. And thank you.